Okay, 7.2 day 2 are some tougher problems with rational exponents. Now, yesterday's video, we talked about two little tips that I kind of want to reiterate again. The first one, if you have the same base, then you're going to use the exponent rules. Exponent rules. We got our 7 rules, those 2 more with the indexes. Same base, exponent rules. If we have the same exponent, then we're going to multiply or divide the bases. All right, so those little two tips there should help us out a great deal here. So for example, number 1, 5 to the 2/3 times 5 to the 4/3, they each have the same base. So we're going to use the exponent rules. In this case, we would add those. We would get 5 to the 6/3. 6/3 reduces to 2. So here the answer is 25. 2 is another one that has the same base. What's the exponent on the bottom 3? The bottom 3's got an exponent of 1. So what do I do with those? I subtract those exponents. So this is going to be 3 to the 1/4 minus 1 is 3/4. Oh, excuse me, negative 3/4, right? So what do negative exponents do? Negative exponents bump down. So now we're at 1 over, now I want to, well, 3 to the 3/4 power. How do I write 3 to the 3/4 power? Well, that's going to be 1 divided by the 4th root of 3. The problem is, though, we got a radical in the denominator. Oh, there's a bigger problem. Should be to the 3rd power. My bad. So the 4th root of 3 cubed. There's a radical in the denominator. In order to get the radical out of the denominator, we have to rationalize it. Now, in order to get out of 4th root land, you need 4 things. We have 3 3's inside there, so that means we need 1 more on top and bottom. Oops, 4th root of 3. So here our final answer is going to be the 4th root of 3 over 4th root of 3 cubed times the 4th root of 3 is 4th root of 3 to the 4th, which means just a 3 is left behind. So our final answer is that guy right there. Number 3, multiply the exponents here. So we're at 7 to the 5/3 power. Multiply, you get 10/6 reduces to 5/3. So put this in radical form. We got the cube root of 7 to the 5th power. All done, right? Not quite. Check it out. How many 7's are inside of here? There are 5 7's inside the radical. And all I need is 3 to get out. So how many can come out? Well, 1 7 can come out because there's 5 of them inside of there. And 2 7's or 7 squareds get left behind. So 7 times the cube root of 7 squared or 7 times the cube root of 49. I'd also accept that one. All right, so these we're using the same properties that we have. It's just that these problems take a little bit of extra work. They're not necessarily hard. They just take some time. So 3 to the 4th times 4 to the 4th. Since they have the same exponent, we're going to multiply or divide the bases. So in this case, this is 12 to the 1/4 power. But remember, our final answer should always be in radical form. No fraction exponents. So this is the 4th root of 12. 5. 5, you multiply this, the cube root of 2 times the cube root of 4. Since they're both in cube root land, we can multiply them. The cube root of 8. Now, what times itself 3 times is 8? Well, another way to think of it is, what's another way to write 8? 8 is also 2 to the 3rd power. The cube root of anything cubed is just the base. So our answer here is 2. 6. 6 is another one. Same exponents, divide. 240 divided by 5 is 18. I believe. I don't think it is it? Oh, snap. I'm just going to restart. Yeah, no, 18 is wrong, isn't it? It's not 18. 240 divided by 15 is indeed 16. So this is 16 to the 1/4. That one got me all flustered. I had to pause for a minute and go and get my calculator. So 16 to the 1/4 is the 4th root of 16. What times itself 4 times is 16? Again, that is also 2. All right, so we did these first 6 problems. Same thing. Tell you what, pause for a moment and try these next 6 on your own. Let's see if you get those. And then start up again, and I'll walk through these very quickly. All right, so go ahead and pause. Ready, go. All right. So I'm going to hook these up very quickly here. So hopefully for number 7, you add the exponents. 1/3 plus 3/4 is 2 to the 13/12 raised to the 1/2 power still. So this is 2 to the 13/24 power. So 2 to the 13/24, remember no fraction exponent. So this is the 24th root of 2 to the 13th power. Now, you need 24 things for something to come out. Can any 2's come out? No. So we're finally done there. This is the 24th root of 2 to the 13th. All right, 13 to the negative 5/4, that would be 1 over 13 to the 5/4 power. The negative bumps it down. So that is 1 divided by the 4th root of 13 to the 5th power. Now, before I start rationalizing here, there's 5b. Before we try rationalizing the denominator, see if anything comes out first. It's 4th root land. We have 5 in there, so a 13 can come out. 4th root of, and then there'd still be 1 left inside of there. So now, while there's 1 left inside there, we still need how many more? We need 3 more. So this is 13 to the 3rd on top and bottom. So you should get the 4th root of 13 to the 3rd power over. Now here's the thing. A 13 came out, but there was already a 13 outside. So this is 13 times 13, or 169. 169. And number 9, take care of these inside exponents first. This is 5 to the 2/3 times 1/5 is 2/15. Quantity squared still. So this is 5 to the 4/15, which is the 15th root of 5 to the 4th power, which is the 15th root of 625. Either of those would work. I would prefer, remember, if it's less than 1,000, I'd rather the number. Everybody knows what 625 is. 5 to the 4th, that's kind of more of an abstract. So I would prefer, if it's less than 1,000, write the number. Number 10, there's a whole mess there on the inside. So let's handle that first. This first part of the mess, this would become 2 to the 6th times 2 to the 8th, which would become the 7th root of 2 to the, now I add those exponents, to the 14th. Now, it's 7th root land, so you need 7 buddies. There's 14 in there, so 2 pairs of buddies come out for a total of 2 2's, which is 4. That whole mess turns into that cute little 4. Number 11. Number 11 looks intimidating. Don't let it scare you. Let's worry about this top first. Now, this is the square root of 3/18 times the square root of 3. Since they're both in square root land, I can multiply those and get the square root of 9/18 divided by the square root of 5. All right, so the square root of 9/18 is, that's the square root of 1/2 over the square root of 5. Now, since they're both in square root, we can think of it like this. The square root of 1/2 divided by 5. And if I if I have a fraction divided by a number, we would multiply by the reciprocal of this bottom one. Might be jumping a little bit, but this is 1 divided by 10. 1/2 divided by 5 is 1/10. Which again reduces to root 1 divided by root 10. We got to get that 10 from out of the denominator, so we multiply top and bottom by root 10. And so our final answer would be root 10 divided by 10. Now, is this the only way to get this answer? No. There's a lot of ways to attack this problem. That's just how I went. I went and got the top together and then unradicalized it, so it's just one big giant fraction, a complex fraction. And then from chapter 9, we know how to handle that. Now, those were the same houses or the same exponents, so we can multiply them. Here, again, we're back to the same bases. This would be 10 to the 5/6 minus 4/6 would be 1/6, just straight up the 6th root of 10. 13 and 14. Again, same bases, subtract the exponents. So we would get x to the 3/3 power, which is x to the 1st, which is just straight up x. There's 13. 14, no, they don't have the same bases, but they're in the same house. They're in the same exponent, or the same house. So the square root of 12x squared divided by the square root of 3 would be the square root of 4x squared. What's the square root of 4? 2. What's the square root of x squared? X. So our final answer there is x squared. Oops, I'm moving the screen on you. Page 2. Now, this is the 5th root of this whole big mess. We're going to simplify this radical. Now, 64. What multiplies to 64? 8 and 8. And hopefully by now we're starting to realize that 8 is how many 2's? 3 2's. So for a total of 6 2's. So since this is 5th root land, how many 2's can come out? There's a group of 5. So 1 2 can come out. Well, 1 got left behind. We'll come back to that one guy in a minute. Let's go to our x's. There's 23 x's in there. We need groups of 5. So here's the thing. You're going to divide 23 divided by 5. 23 divided by 5 is 4. So 4 x's come out with a remainder of 3. Right? A remainder of 3. We'll come back to that guy in a minute. Y's. How many y's can come out? 3 y's can come out with no remainder. And then z's. How many z's can come out? Well, there's 47 divided by 5. You get 9. So z to the 9th with the remainder of 2. So 2x to the 4th, y to the 3rd, z to the 9th times the 5th root of, now let's go back to 64, a 2 got left behind. X's, a 3 got left behind. Did any y's get left behind? Nope. But z, 2 z's got left behind. That's our final answer there. All right, so I want you to pause it. Try 16 yourselves. It looks like a big giant thing with alphabet soup and scary radicals. It's not that bad. Go ahead and pause it. Give it a shot. Ready, go. Welcome back. I'm hoping that you did this. The 4th root of... Oh, excuse me. I'm getting ahead of myself. Since it's the 4th root of a big fraction, we can do the 4th root of the top divided by the 4th root of the bottom. So the top, 4th root, how many x's come out? X squared, y to the 3rd, z to the 5th, right? I divide each exponent by the index, and that's how many come out. The remainder is what is left back inside of here. So this would be x to the 5th, y to the 3rd, and z squared. 22 divided by 4 is 5 with a remainder of 2. Over, now the bottom, straight up 3 a's come out, and 1 b comes out. Unfortunately, 2 b's got left behind. Now, we're almost done, except that the problem is we've got a radical in the denominator. It's 4th root land.